Hello everyone. It's my great pleasure to see you all again. In last video, we have seen preservative methods by using instrumental analysis. In last video, we have gone through HPLC, GC, UV and MS. In today's section, we are going to analyze or we are going to learn about TLC, capillary electrophoresis, calorimetry. Thin layer chromatography. So this thin layer chromatography, it's very useful to test the preliminary screening of preservatives. In the food, if there is a preservative should be added, the primary screening test should be carried out by this thin layer chromatography. Here there is given a procedure to analyze the preservative screening test. The sample is applied to a plate coated with a stationary phase. A solvent moves up the plate by capillary action, separating the components. The separated parts are visualized and compared to standards. Just we can see briefly how the working should be carried out in the TLC. First, we have to prepare the preparation plate. A thin layer of solid adsorbent, it may be typically silica gel or alumina, is coated in a glass, plastic or aluminium plate. This layer acts as the stationary phase. After preparation of TLC plate, the sample parts of a small mixtures are applied near the bottom of the plate. Near the bottom of the plate, this part should be a small as possible as small to ensure distinct separation. A solvent or mixture of the solvent is poured into TLC plate. It should be a development chamber. This is called as a TLC chamber. A solvent or mixture is poured into a TLC development chamber, ensuring the level is just below the origin line on the TLC plate. After that, the TLC plate is placed vertically in the chamber. Capillary action moves the mobile phase the plate, carrying components of the sample at different rates based on the polarity affinity to the stationary phase. After the solvent front has moved an adequate distance, the plate is removed and dried. The separated components can be visualized under UV light or by staining agents if they are not visible naturally. The distance of each component traveled is measured to calculate the RF factor, that is retention factor, which is unique for each compound under specific condition. RF values are used for identifying, analyzing the components in the mixture. We already know that the RF formula, that is retention factor formula, is distance traveled by the substance, distance traveled by the solvent friend. So by using this formula, we can easily calculate the retention factor. So the different types of food items should be taken, and the different distance should be traveled by each component should be calculated by the TLC. From this ratio, we can identify how much of preservative should be added in the food sample. So this is the procedure for TLC. The next one is capillary electrophoresis. It should be shortly denoted as a CE. It is very suitable for analyzing the ionic preservatives. This method is very useful or suitable for analyzing ionic preservatives present in the food. So this is the schematic diagram for the CE. Here this is a short procedure they given. The sample is placed in a capillary tube and an electric field is applied. Components separate based on the charge and size and are detected as they are passed through the detector. So this is they given a single line how they are working. We can see briefly how the process should be carried out in the capillary electrophoresis. First, we have to prepare the capillary and buffer solution. A narrow capillary tube, it should be usually made up of a fused silica. It is usually made up of fused silica, is filled with a buffer solution. This capillary tube is filled with buffer solution. The choice of buffer, its concentration and pH are essential as they affect the separation process. After preparing the capillary and buffer solutions, we have to prepare or we have to inject the sample into that capillary tube. A small volume of the sample is introduced to the one end of the capillary tube. This can be done using pressure or gravity or an electric field. It may be applied by through pressure or gravity or electric field depending on the techniques. Okay. After injecting the samples, we have to apply the electric field through this solution. High voltage is applied. High voltage is applied across the length of capillary tube, creating an electric field. This electric field causes ions in the sample to migrate through the capillary at different speeds depending on the size to charge ratio. The left hand side, it should be in the sample source, conductor the cathode. At the same time, right hand side, the sample should be connected with anode. This cathode and anode will be connected through the electric field. While we are applying the electric field through this anode and cathode, migration should be started. The migration should be started. The electric field, once the electric field applied, it causes the ions sample to migrate through capillary at different speeds, depending on the size to charge ratio. The components in the sample separate based on the charge, size, and shape. Positively charged ions move towards the cathode, while negatively charged ions move toward the anode. Neutral molecule can also separate due to electroosmotic flow within the capillary, which can affect the movement of sample components. Again, I am repeating, positively charged ions move towards the cathode, while negatively charged ions move towards the anode. In case of neutral molecules present in the sample, it can also separate due to electroosmotic flow within the capillary itself. This can affect the movement of all sample components. Okay. After that, we have to separated ions or reach at end of the capillary. See, there is a charged ions. Okay. Separated ions reach at the end of the capillary through a detector. We may use the detector containing UV visible or fluorescence lights. While we are passing the separated ions through detector, the detector records the signal as peak as an electrophotogram corresponding to each component's migration with time. Okay. After the migration time of each peak shows a different compared to known standards, and peak areas or heights can be used for the quantitative analysis. Each peaks denotes as a different types of compounds. From the peak, we can identify what are the preservatives should be added in the food products. Okay. So this capillary electrophoresis is very suitable for analyzing the ionic preservatives present in the food sample. Okay. The next one is calorimetry. This calorimetry is widely used for the preservatives that produce a color reaction. So calorimetry, we know that it's a test of coloring. Okay. So what is the food color? It should be identified by calorimetry process. Okay. So this is the working process of calorimetry. So the sample reacts with a reagent to produce a color. The intensity of the color is measured and related to the concentration of preservative. We can briefly explain this working process of calorimetry. First, we have to prepare the sample and standard solution. First, we have to prepare the sample and standard solution. So, preparing the sample solution and several standard solutions with known concentration of the analyte. Then only we can easily identify the color intensity of the solution should be directly proportional to the analyte concentrations. So, we have to prepare the sample solution with several standard solutions. Then only we can get the clear idea about that. After preparing the sample solution, we have to prepare the wavelength of the colorimeter, wavelength of the light what we have taken. Using this colorimeter, select the appropriate wavelength of light that corresponds to maximum absorptions of the analyte. Then only that wavelength is chosen to enhance the sensitivity and accuracy. After the selection of wavelength, we have to use the calibration curve creations. Then only we can measure the absorptions of each standard solution at the selected wavelength. Then we have to draw the graph by plotting the absorption values against the known concentration to create calibration curve, which is used to determine unknown sample concentrations. After that, we have to place the sample. After that, we have to place the sample solution in the covered tube, ensuring that covered tube is clean and free from air bubbles. Then we have to insert the cover into the colorimeter and measures the absorptions of the sample at same wavelength. After that, we can easily identify the concentration. We can easily identify. How we have to identify? By using the calibration curve, determine the concentration of analyte in the sample by matching its absorptions to the corresponding concentration on the curve. After that, we can observe a different type of measurement of sample should be observed in the plate. This is the final, this is the initial stage. After the time moves, this is the final stage. After that, the sample should be placed in a covered. After that, we have to calibrate the curve to determine the concentration of analyte in the sample by matching the absorptions to the corresponding concentration on the curve. Finally, we have to calculate and analyze the interpretations by using the data analysis what we have received. Analyze the concentration data needed, comparing it with expected values. Then colorimetry is typically used in the applications like water quality testing, biochemical assays, and food industry quality control, etc. So, by analyzing the concentration of data itself, we can easily identify how much of color should be present in the sample. Okay, so it should be this colorimetry also relies with the principles of Beer-Lambert's law. That means Beer-Lambert's law, we know that, which states that absorption is directly proportional to the concentration. What sample we have taken, how much concentration we have taken, it should be directly proportional to the absorptions value. From that calculation, we can easily identify the colors of the food. Okay, so this is colorimetry process. So in this session, we have seen three instrumental analysis. One is thin layer chromatography, TLC. The second one is capillary electrophoresis. The third one is colorimetry process. By using TLC, we can screening the preservative of food. Using capillary, we can analyze the ionic present in the preservative items in the food. By using colorimetry, we can easily identify the preservative colors in the food products. Thank you all. We will meet in the next class.